Hello and welcome back to Equity, TechCrunch's flagship podcast about the business of startups. I'm Rebecca Bellan, and this is the episode where we bring on industry experts to help us explore a trend in the tech world and dive deep. Today, we're exploring the business of space defense with the help of Evan Rogers, co-founder and CEO of True Anomaly, a defense-focused aerospace startup developing spacecraft and software for U.S. national security missions. Evan joined us last week at Disrupt to talk space stuff, and so we're excited to give him some extra airtime. Evan, welcome to the show.
Thanks, Rebecca. It's great to be here.
So I'm really excited to talk to you because, and this might sound stupid, but I'm kind of a big Ender's Game Star Wars fan, and I'm like, space defense? Is it coming to life? Is it real?
Very good company. I mean, really, the starting True Anomaly is really just a ability for me to get my fantasies of Ender's Game out of my system,
Oh, amazing. Great. I love that. Okay, so when did you start the company and why the name True Anomaly?
I started the company in 2022. I am an Air Force weapons officer. And as with all stories, there's the true story and then there's the 10% truth story. So I'm going to give you the partially true 10% truth story, which is there are these 6 classical orbital elements that define a position of a orbiting body around the orbited body or a spacecraft around the Earth, for example. And those are well known in my community and well known if you're involved in sort of any type of orbital mechanics or astrodynamics work. The only cool one is True Anomaly. The others are like right ascension of the ascending node, semi-major axis, et cetera. And you just can't really brand around that. So we went with the cool one. There's another version of the story which is just about really the knowledge base that exists in the Space Force today and how difficult it is to train for and prepare, at least when I was serving for space warfare, because there really weren't agreed upon doctrine and tactics and educational modules, and that stuff is just getting built. So it's a little bit of a tongue in cheek, but that one's over a beer.
Okay, yes, very disruptive. I love it. So you said you are still an Air Force officer, former?
No, I was an Air Force officer, but there's a bit of a saying that once you're a weapons officer, you always wear the mantle.
Okay. All right. Great. So tell us a little bit more about like what exactly you're building. Like what does it mean to build defense spacecraft?
Yeah, it's a great question. So a lot of space companies, by the way, are dual use companies. They're selling to the Department of Defense or the intelligence community, and they're selling to commercial customers. We are exclusively a defense company. And that's because we think that the world has changed in such a way that and we'll talk about why this is true, I'm sure. But the world has changed in such a way where we need to build purpose-built space superiority systems. So we need to build offensive capabilities, defensive capabilities, training systems, and targeting and reconnaissance and surveillance platforms, but purely for intelligence applications and military applications. So what True Anomaly does is we build a full stack of those capabilities. We build payloads like surveillance systems. We build spacecraft that are platforms to host those payloads, and we build autonomy and software to tie these capabilities together and operate them in the field.
Wow, that's a big mission. There's a lot going on there. I mean, like all of these can be their own separate companies.
For sure.
I guess the problem is really that you could maybe focus on the software, but the spacecraft doesn't exist in the way that you want it to, or...
Yeah, that's part of the problem.
Yeah.
That is part of the problem. Attacking just the spacecraft means that you're really subjecting the spacecraft's performance envelope. You're defining the spacecraft's performance envelope by the software that would fly it. So we can build like a very, very high performance capability, but in the same idea with aircraft, if you put like a novice pilot in an F-16, for example, you're not going to get the performance out of that aircraft as you would a very experienced pilot. So you need to have the brains operating the spacecraft, which means you need to have sophisticated command and control software and autonomy. So you really, to really solve the problem, you have to solve the spacecraft problem, you have to solve the autonomy problem, and you really need to build this next generation of sensors and effectors that are explicitly for space defense and space superiority. It's just, these are different types of products than exist on the market today. So we've had to do a lot of this ourselves.
Yeah, so it's real vertical integration. You're the hardware, the software, and the supplier of the sensor suite. That's pretty crazy. So how many employees have you got working on this big old mission you got there?
Last time I checked, 222 are working on this mission, and we plan to be 250 by the end of this year, and then likely 350 to 450 next year.
Right. Okay. And then so you've raised about 418 million to date. Is that correct?
About 400 million.
Right. So $260 million Series C in April this year, led by Excel. So most of that, I assume, is going towards finding this like special blend of employee that is both a brilliant engineer and also maybe has some military background, or?
Actually, what you just pointed to, Rebecca, is a really important part of the DNA of True Anomaly, which is these kind of three groups of people that come together around this problem. One are operational experts and people that built tactics and wrote documentation around these tactics and maybe did the applied research for them. People like me and my other colleagues that are here at True Anomaly. There's a second group on the engineering side that has experience in large system integrators. So companies like Northrop Grumman, companies like Boeing and Lockheed, we need to be intelligible to our customers. So we have to find the balance between being a fast-moving, vertically integrated startup that focuses on solving the problem in a vertically integrated way, but also be able to engender trust through having the right structure and process. Not structure for structure's sake, but not process for process's sake, but really the discipline that's required to field these capabilities at scale and get the customer to give you confidence like immediately so that you can go take really, really big swings at bat. And then the third kind of group of folks that we have here are people that come out of new space, right? That are a bias towards hardware, a bias towards flight test, who know how to fly, fix, fly, break things. And we're not just the people in the room, right? But are the people that are the world's leading expert in design of an optics suite or of a propulsion capability.
Okay, so where are you at in terms of, have you tested your spacecraft in space? Have you sent payloads out? And also, forgive me if you've already said this, but like what kind of spacecraft is it? Are these satellites? Like what are we looking at? I'm trying to imagine something.
So let's start there. So our first product is called Jackal. Jackal is what we call an autonomous orbital vehicle. It's designed to conduct space-to-space engagements. So it's designed to move from its starting location in orbit. So after it's launched into orbit by a rocket like a SpaceX Falcon 9, for example, or a Vulcan or a Blue Origin rocket, it moves from its location into proximity or the vicinity of another spacecraft in order to perform a wide variety of missions, like taking detailed imagery, high resolution imagery of that target or full motion video in different spectra. And Jackal's special because we're packing a lot of capability as a multi-role platform into a form factor that's called an Espa Grande class spacecraft. So it's about 1,000 pounds, anywhere between 750 pounds and 1,000 pounds. And it fits in this volume that's been defined by industry as used by SpaceX that allows us to deploy lots of them on a single rocket very quickly. And it generally means that we're less expensive than our competitors, which are largely the primes. So Jackal's designed to pack this massive amount of capability into a really small form factor. And it has a ton of maneuverability, high thrust, high acceleration, high what's called delta V. We knew that this system was going to take a couple of swings. So we split the development program into 3 flights. The third one's coming up here in Q1 of next year. But we've already gone through 2 flights, learned a ton, and we've been iterating on that system ever since. So the first flight was in March of 2024. The second flight was in December of 2024. And now we're gearing up for our third.
Mm-hmm. And these are, sorry, again, are they testing flights or do you have customers already?
Yeah, these are test flights, and we're gearing up for a paid customer demonstration called Victus Haze in the middle of next year, which is the flagship demonstration for the Tactically Responsive Space program. And that's really the first attempt for the United States Space Force to demonstrate this end-to-end capability to be able to identify an object in space that is unknown, be able to characterize that object, and then report back as to whether that object is a threat or not. But to be able to do that on timelines that are less than 24 hours.
So this is more of like a surveillance system, right? Like we're being able to identify when there's something off. But
That's right.
Are these vehicles, attacking objects or anything that, that might be, let's say there's from an adversary country, if they're attacking one of our satellites or trying to spoof or something like that, which I imagine is one of the threats that we're exploring here. Can your spacecraft also defend against that, or what do we...
Yeah, the way to think about Jackal is as a multi-role system, right? So it's designed for surveillance, but what the United States military does with many surveillance platforms is you start to put weapons on them, right? And defensive systems, countermeasures. So we think Jackal will go through that evolution as well. Right now, it's a reconnaissance platform, but it's a multi-role capability, which means it can host different types of payloads that are dependent on, that are really driven by the type of mission that we're trying to perform, that the Space Force needs to perform. So it's a reconnaissance platform today, just to be clear. there. But the Space Force has made it very clear, and more broadly, the Pentagon and this administration has made it clear that the United States now has to achieve space superiority. We're pretty far behind our adversaries, and that means that we need to be able to build and proliferate a wide variety of offensive and defensive capabilities and supporting targeting systems to be able to protect the joint force on the ground, which means if necessary, we got to engage spacecraft on orbit with US and allied systems to be able to make sure that our adversaries can't use the space domain to do long-range munitions targeting, for example.
Okay, so that's one threat. Yeah, talk me through, like, what are we really worried about here? Why is there a need for this at this moment?
Since 2004, China started building space weapons. The first weapon that they started building was as a system called a direct descent anti-satellite weapon. So it's very similar to a surface-to-air missile that's been used, regularly in combat since the 1950s. A similar concept applies to space, where you have a missile that's designed to go into space to kinetically intercept and engage a spacecraft. China has systems that are built to engage targets as low as 300 miles and as high as 22,000 miles. Russia has systems that are designed to go up to 2,000 miles. That's one class of threat. There are other classes of threats like co-orbital anti-satellite weapons, which are basically spacecraft armed with weapons that are designed to engage other spacecraft. And then there are even scarier systems that China's been working on called fractional orbital bombardment systems, which was actually a concept that came out of the USSR in the 1960s and was one of the major concerns that around Sputnik was like, hey, can the USSR drop nuclear weapons from space on the United States, and led to a lot of the non-proliferation work. So that's kind of the broad set of categories of space weapons. And frankly, we're concerned about all of them.
So mostly space weapons, not just like messing with our satellites that could screw up all the GPS and critical infrastructure that might be reliant on satellites and things like that.
A lot of those systems are actually considered space weapons. Like a GPS jammer, you wouldn't think of it as a space weapon, but it's an electronic warfare capability designed to target a space link. That's technically a space weapon.
Okay. So then what was your aha moment that made you realize that this needed a new approach, that space needed a new approach to security and situational awareness?
It was a bit of a slow burn over the course of my 10-year Air Force career. I started in the Air Force as a traditional satellite operations officer. So I was the guy, one of many, who would make sure that our satellites that were doing a variety of really important national security missions were taken care of. And we started to get reports of threats coming out of China that were designed to engage the types of systems that I was flying. And I couldn't go to a tactics manual to find a reference for how to use my spacecraft to defend itself. It was designed in the 1980s or the 1990s or maybe the early 2000s if we're lucky, and just was built and designed in an era where space weapons weren't really an issue. So we didn't do the background work that other services have to do as combat arms organizations, where you have to figure out how to employ and build your capability and survive in combat. Space community was a service community, like service-oriented community in the sense of providing services to the rest of the joint force. So that was an early recognition that we just didn't have the culture, the doctrine, the tactics, and the capabilities to really defend ourselves. And that was a through line that I explored over the course of my career that ultimately led to a moment when I was in my final assignment called Joint Task Force Space Defense, where Russia had recently launched a space threat. And I had a general officer approach me on the floor there. I was a fires officer on the National Space Defense Center floor. He said, "Hey, Jolly," was my Air Force call sign. "This threat just launched. Like, we're putting together some options. Like, what's in our arsenal of capabilities to go do something here to provide options to the SecDef, United States Space Command commander." He said, "Nothing. And if you ask me again in 5 years, that all signs point to that being the same answer." And so I realized that the Space Force didn't have an industrial partner that could work at the intersection of operational concepts and new technologies and really build systems that were purpose-built for space superiority.
Right. So you want to be that kind of supplier or one of like the main companies that works with the DoD and with the Space Force in order to supply this kind of niche, almost like hyper-specific piece of tech.
Yeah, hyper-specific now, but growing in scale and importance for sure.
Do you have any competitors? Like, who else is doing this?
There are no companies that work that build defense products for space superiority exclusively. There are companies, again, that have a dual use thesis, or there are companies that have space superiority product development cohorts within them, principally the large system integrators like Lockheed, Boeing, Northrop, et cetera.
It's like Leo Labs. They're doing something with satellites, but maybe not.
Not really. Yeah, they're a
They're more
space
low.
surveillance company. Yeah, but we're the
Yeah.
only space superiority product company in the world.
And then talk to me a little bit about the autonomy aspect of it. So you had a stint at DARPA, if I'm
That's right.
correct. Yeah. Okay. So how is it different building autonomous pursuit vehicles for space versus like how are you approaching AI and autonomy in space versus in terrestrial applications? Like there's a lot less data to train it on, I imagine. The physics are completely different. Like this seems like a really hard problem to solve.
It's actually really, really similar to other domains. The same basic principles of autonomy apply. It is definitely difficult to train models on data. We have very sparse data for visualization in the space domain, in particular, what objects look like. So there's a lot of synthetic data generation that has to be done there, and then model training off the back of that synthetic image generation, then validation once you're on orbit.
Are you building your own simulation models or are you at least outsourcing there?
We're building our own.
Okay.
Autonomy in the space domain, in many ways, is more straightforward than in other domains. If you're building a vision system for a vehicle, you have to contend with a lot more visual inputs and a lot more unknowns. In space, the star field is static, the background is static. We have predictive models that are very straightforward for what the Earth is going to look like, how weather models can be incorporated into them. We can understand what the Earth is going to look like in certain seasons, for example. And we can predict what lighting is going to look like on a target. That's relatively straightforward. Orbital mechanics is also well understood. So really, the purpose of autonomy in space is to solve challenges of latency and lack of connectivity. So when you're communicating with a spacecraft that's in geosynchronous orbit, for example, you have about a 1 to 2 second round trip timeline. And that can make the difference between being successful and failing in engagement or finding yourself in an unsafe situation. And so you need a lot of onboard autonomy to make sure that the vehicle is following the trajectory that you set out for it and can react as the situation unfolds.
Yeah, I imagine there's the latency for any kind of remote operation would be
That's exactly right. That's
horrible.
exactly right.
Yeah.
And then the last piece is you're not always in communications with your spacecraft. So you need the spacecraft to perform its mission even when humans aren't available to joystick it.
Wow. Okay. You would have to do a lot in simulation because even while the risks may be lower if you're testing in space, like the cost of doing those tests would be astronomical.
They can be, but they're like way less expensive than they used to be.
Yeah, and that's because of, the SpaceX commercial infrastructure that's been developed over the last decade or so.
That's right. The cost of launch has come down by orders of magnitude. It's made it possible for companies like True Anomaly to deploy regularly.
What does it actually cost to build and launch each of these?
The launch costs are anywhere between $500,000 to $2 million, depending on the weight of the vehicle and the size of the vehicle. Our bomb is far less than $10 million. I won't give you specifics, but they're orders of magnitude less expensive than the competition that we're really trying to unseat, which are the primes.
So, I mean, I know you said that you're trying to work on a lot of development of your own sensors and things like that, but in terms of just like parts, are you getting lots of off-the-shelf parts? Are you finding ways to make this a bit cheaper in the way that we've seen? I think SpaceX has done this. Anduril obviously is doing lots of off-the-shelf parts. There's a lot of ways to make it cheaper.
Yeah, the supply chain is much more mature than it used to be 10 years ago. I mean, a company like True Anomaly really couldn't have existed at the scale of capital that we've raised and deployed so far a decade ago. And that's just because low-cost launch has driven this ecosystem of capabilities that are flight proven. And so you can really take components that are off the shelf and integrate them effectively. Again, our goal is really to focus on the performance characteristics that really matter in a space-to-space engagement, and that's sensing, autonomy, fast transients, and propulsion. And so that's where we put our capital, and that's where we either partner in kind of long-term relationships where we have control over the product roadmap or influence over the product roadmap, or we bring it completely in-house. And then we wrap all of that in Mosaic, and that's how we get the full performance out of the capability. But largely, we've been able to rely on a relatively mature supply chain.
Mosaic. Sorry, did you mention what that was already?
That's our software platform.
Software platform. Okay. Are you working, I imagine that you're working quite closely with the DoD, with the intelligence community. You talked about the fact that the supply chain is really developed and that's making things a lot easier. How is the relationship with government agencies in this day and age? Like, is that, a headwind or a tailwind?
It's a tailwind for us. There's a lot of interest in the Space Force in what industry is building and how the Space Force can leverage industry and innovation coming out of industry to solve the Space Force's most acute problems. Space Force needs to get some wins, right? They need to have some successful acquisitions, and they need to field capabilities in order to be a productive member of the rest of the joint force alongside the Air Force, the Navy, et cetera. So they're very open to input from industry. We have a very close relationship with our customers, and we actively strive to build that because we are interested in their feedback in our product roadmap. So while the product roadmap is ours, right, Jackal and Mosaic, we seek feedback to influence the development of that roadmap over time to make sure that we're building the right thing and we can iterate as the threat evolves and as operators change the way that they use systems.
Well, I imagine that the development cycles are not the shortest for something like this, and then maybe that suits you and the way that it takes a long time to kind of get contracts with government agencies. Does it kind of work in your favor?
The long pole in the tent is definitely government contracting and the planning, budgeting process in the Pentagon. True Anomaly is executing upgrade cycles, incremental upgrade cycles on its Jackal spacecraft every 3 to 7 months, and then major increments every 12 to 24 months. So we're operating at a pace that exceeds what the government is really capable of ingesting from a product standpoint. And so what we're trying to do is educate the Space Force on how best to partner with industry to take advantage of our pace of iteration.
Okay, so talking a little bit about investment and the kinds of questions your investors are asking, I saw a recent Reuters report from this month that investors have poured $3.5 billion into space as investors are looking beyond big names, right? So what excites your investors the most, and where do they want to kind of double click and learn a little bit more?
Yeah, our investors are excited about space superiority, full stop. They
Yeah.
recognize that we have a unique place in the market, and they recognize that there are analogies between what's going on with space superiority product development and what happened in the late 1930s in air platform development. About a decade after that, you had the stand up of the Air Force, and then suddenly you had $10 trillion over the course of basically 60 years, $10 trillion worth of air superiority acquisition coming out of the government. Our investors are excited about the fact that the United States has and its allies have recognized the space domain as a warfighting domain, have stood up a service, and are now funneling resources and reallocating resources into space superiority specifically. They're starting to come up the learning curve on the fact that space companies are not all the same and satellite companies are not all the same. So there's actually, you asked for a double click, there's actually an education that we have to do with investors to make sure they understand that the ecosystem of space companies are differentiated from each other. Us in particular, we're not just building commodified spacecraft to ship them to different companies who are going to go do their own development and operations with them. We're building for a specific customer. Lockheed Martin doesn't sell the F-35 to United Airlines, right?
Yeah. Okay. So you're not doing a dual play here. This is
No,
okay.
we're not.
All right.
We think it's dilutive of our product and our mission.
Another question is, you've raised, again, 260 million Series C this year. What advice do you have about pitching deep tech hardware to investors who've been burned recently by capital intensity? I mean, defense is hot. People are frothy about it in a way. If there's AI first, I think defense comes after. And this obviously has AI applications. But yeah, there's a long road to profit.
Yeah, so I think deep tech and defense are two different categories, and then you bring them together and it's especially challenging. So I think my advice to entrepreneurs is make sure that your investors understand both of those landscapes. They have an investment thesis that supports deep tech timelines and defense timelines. The externalities of defense drive schedule. Deep tech's hard enough by itself, right? If you're actually biting off something that's very, very challenging, it's going to take longer than you anticipate. Then I'll talk about how we've communicated that to investors and how to show progress. But also the customer that True Anomaly and other defense companies are selling to can be quite fickle. I mean, once you get in with a program office, there's sustainability there generally. But the government shutdown is a good example of this. Like there are program timelines that are moving right by 3, 6, 9 months because of the uncertainty around budgets. Then if you're a company that has 6 months of runway, right, your next increment of value from a programmatic standpoint could be now pushed out way beyond your runway. And so
Wow.
you need to set expectations with investors about pre-agreed upon incremental progress that if you achieve that, that can unlock, potentially additional funding, or you have a narrative around the ability to go back out to market and say, hey, look, even though these programs are still pushed to the right, like here's the progress that we can show, and it's worth continuing to invest in the business.
So if you don't mind, like quickly, what are some of those metrics and KPIs or what have you that you can show investors?
Test activities on the ground is a good example. I mean, especially for space companies, like don't hinge your entire company's fate on one flight test, right? We broke our flight tests up into 3 different on-orbit tests, but those are supported by dozens and dozens of ground tests. So there's lots of opportunities to show that the team and the process and the infrastructure is being invested in appropriately, and that machine is generating outputs in the form of a working product. And we can point to vibration table milestones or TVAC milestones, thermal vacuum test environmental milestones as just very simple examples.
Big picture, should we be more worried about space debris and accidents? I think we had one recently this month. Is this something we should be more worried about? I mean, we're talking about potentially blowing adversary weapons out of the sky in the future. So is this something that you're worried about or?
Yeah, I think you have to be cognizant of space debris. Space is big. It's not yet totally congested. I think some of the commentary around a congested space environment is overblown and largely self-serving by the folks that are articulating that. Space is contested, and by virtue of the fact that it's contested, the employment of a weapon, particularly a kinetic weapon that generates debris in space, can create the congestion that then creates the cascading effects, often known as the Kessler syndrome, where you have, sort of like the movie Gravity, where you have stuff that's blowing up and then hitting other things, and that generates a ton of debris. And then before you know it, space is basically inaccessible. So I think those are real risks, and they need to be watched. And there are standards in place now to make sure that space operators are deorbiting their systems within a certain amount of time. So I think the right steps are being made. Tracking is a really important piece of this. Like, do we know where everything is at the right resolution? That's really, really difficult. Companies like Leo Labs are working on that kind of problem. Unless mitigated and unless controlled, it will get out of hand. But I think we're not at the tipping point today.
Okay, great. Well, I think we're just about out of time. Thank you so much for joining us. Where can our listeners find you if they want to connect online and follow your work?
I'm on LinkedIn, or you can go to trueanomaly.space.
Great. And to our listeners, you know where to find us. We're on X, we're on Blue Sky at EquityPod. Talk to you next time.